in science, sometimes we have to do math, but we don't do math on numbers generally. We do math on measurements. And if you've already watched a video on that, measurements are not numbers, that they are always have ranges associated with them, then that kind of could make it somewhat difficult to be adding measurements together, which seemed like it should be easy math, but when we're adding ranges together, we need to figure out what kind of rule are we going to apply. So there's two different rules for doing math in science. One rule is for adding and subtracting measurements, and the other rule is for multiplying and dividing measurements. In this video, we want to just look at the rule for adding and subtracting measurements. And the rule is that your final answer, you can add them together in a calculator like you normally do, but your final answer is written to the least precise estimated sig fig found within your measurements. So what does that mean? Okay, so let's just attempt to do a problem here. Let's take a measurement. I don't know what the units are on these things, but there would be some units on them. Let's take 0.056, and we're going to add to it another measurement, 1.27. And if you do this on the calculator, like always, your answer would be 1.326. And these videos are hopefully going to help you to stop asking your teacher, where do I round off my answer to? Because you're supposed to be able to actually figure that out on your own. And when we're adding and subtracting, we use this rule here that this final answer, I can't just write it out exactly like the calculator tells me to. It's not always going to be right. I need to apply the rule. The rule is that I can only write this answer out to whatever was the least precise estimated sig fig found within the measurements. So let's look at each of these measurements here. In this first measurement, 0.056, if you do your Pacific Atlantic method, the decimal point is present, so you would have started over on this side, and you would have counted through in this direction, and you would have known there's only two sig figs. The 5 is something that we know for sure, and the 6 is our estimate. Remember, there's always one digit. One of your sig figs is an estimate. So in this case, the 6 is the estimate. So this measurement, the estimated sig fig is in the thousandths place. Well, what about this other one here? Same thing. We'd start here, and our estimate, that we'd know the 1 for sure, the 2 for sure, but the 7 would be our estimated sig fig. So the rule is, which one of these is the least precise? Well, this first one here went out to the thousandths place, but this one only goes to the hundredths place. So what that means is our answer can only be written to the hundredths place. We can't put another digit out here because although we have the sig fig up here, 6, we don't know what this digit is right here. This is like a question mark. We don't know what that is. So we can only write our answer to the least precise estimated sig fig, which means we're going to have to round our answer to the hundredths place. So we round it according to the rounding rules, and our answer here would be 1.33. Hope you understand that rule. Let's try another problem. Let's take 260. There's a measurement. 260 plus 2.78. So you don't really need to know how many sig figs there are in all these things. You just need to know which digits are significant and which one is the estimate. In every measurement there's an estimated sig fig. In this 2.78, the estimated sig fig is the 8. That's the one we know is an estimate. Technically it means it's somewhere between 7 and 9. But in the 260, what is your estimate? A lot of times people get tricked on this one. They'll think the 0 is the estimate, but it's not. If you do Pacific Atlantic, you're going to be starting on the Atlantic side, and your estimate here, your estimated sig fig, is the 6. We know the 2 for sure, and we know the 6 is an estimate, which means 260 actually means somewhere between 250 and 270. It means one up and one below the tens place. So if I added these together, on the calculator, I'd get 262.78. But that's not a correct answer when I'm adding these two things. I can only write out this answer to the least precise estimated sig fig, which happens to be the tens place. So I need to round my final answer to the tens place, which means it's going to be 260. It's still 260. Now that's bothersome to people because I already had 260 up here and I added something onto it. So shouldn't I have something more? Well, we're not adding numbers. We're adding measurements. And this 260 here means somewhere between 250 and 270. So just by adding a 2.78 onto that, I'm still somewhere within that range. I don't really know where I am within that range still. So I've added something that's pretty insignificant that kind of falls into this range of insignificance of the 260. So I still need to round to the tens place, and so my answer would still be 260. Let's try one more. Let's take a measurement 800, which of course is a really bad measurement. That means it's somewhere between 700 and 900 is all we know on that. And I'm going to add 47.2. So I do this on the calculator. Of course, I get 847.2. But what is my real answer? Well, 47.2, the estimated digit is the 2, the tenths place. And in 800, I only have one sig fig. And of course, if you have one, it has to be the estimated. So we're estimating to the hundreds on this one. That 8 is our estimated. Clearly, that's the least precise place. So my answer has to be rounded to the hundreds place also. 847.2, this is not, the 4 is not, it needs to be more than a 5 to round up. So this just rounds off to 800. And that would be my answer when I add these two things together. So that's the rule for adding and subtracting. You need to round your answer to the least precise estimated sig fig that you find within the measurements that you're adding. Now, I would like to say that all these could be minuses too. If I just subtracted them, I could do that on the calculator. It's still the exact same rule. I would still have to subtract these, and then I would still, for this problem, I'd still have to estimate to the hundreds position. So hopefully that helps you learn how to add and subtract measurements.